Hello students, today we are going to solve this circuit here with Thevenin's theory. We will need to find VTH, RTH, and IRL when RL is equal to 5 ohms, 10 ohms, and 15 ohms. Okay, so the first step in solving this circuit is to find R Thevenin. So to do that, we're going to remove RL, which is a load resistor. We're going to leave a open gap, and then here for the source, we're going to remove the 5 volts and short circuit it. So we'll have to redraw the circuit for that. So we'll have our 2 ohm resistor, second 2 ohm resistor. Then we'll have our short circuit from where 5 volts used to be, another 2 ohm resistor. We'll have our node A and then our node B. Okay, so after we redraw our circuit, our next step is to decide what the R Thevenin will be. So that's also known as RTH. So the way that you find RTH is that you assume current is put in through the A node and it's trying to find the path of least resistance to get to the B node. So we'll start here, have current coming in, it'll come here, and then it has to make a decision. Is it going to go through the 2 ohm resistors, or is it going to go through the short circuit from where the 5 volts was removed? In the case of current, it tries to choose the path with least resistance, especially when there's a short circuit. It will ignore the other resistors for the rest of the circuit that would be more resistance in the short circuit. So in our case, we're going to have the current go here, and it won't even bother going to that side. So the RTH is going to be equal to our 2 ohm resistor, which it has to go through to get to this node, plus 0 ohms because the short circuit has a resistance value of 0. And then it'll be able to return to B. So our RTH will be equal to 2 ohms. So our second step is to find VTH. In order to do that, we will redraw the circuit. We have our 2 ohm resistor. We'll have our other 2 ohm resistor on top. Then we will add back our 5 volt voltage source. We'll have our third 2 ohm resistor, our A node, our B node, and then VTH is the voltage across from A to B. And then our next step is to consider that if A and B are technically an open circuit, that means that the 2 ohm resistance has 0 current flowing through it. So effectively, we can ignore the 2 ohm resistor, basically consider it a short circuit. And because of this, if the current or voltage wanted to get from A to B, it would be equal to the 5 volts. So VTH is equal to 5 volts. And this is also true because once you short circuit the resistance, A and B is parallel with the nodes on top of the 5 volt source. Okay, so our third step in solving this circuit is to write down the Thevenin equivalent circuit. We'll use our VTH that we found and our RTH to redraw it. Then we have to draw our Thevenin equivalent circuit. So our VTH was found to be equal to 5 volts, and our RTH was found to be equal to 2 ohms. So we'll have our 5 volts source in series with our 2 ohm RTH. We'll have our A node and our B node, and then we'll have our RL across it. So our next step is to solve the circuit with RL equal to 5 ohms. And after we solve, we're going to want to find IRL. So first, we'll redraw our circuit, 5 volts. Then we'll have A, B, our 2 ohm at the top, and RL is now equal to 5 ohms. RL. So to do this, we will have our 5 volts, and we're going to use Ohm's law. So V equals I times R. Then we'll have our IRL that we're trying to find, and then we'll have that multiplied by our R. In this case, R is going to be our REQ, also known as R equivalent, which, because they're in series, we're going to add our resistances. So we'll have REQ equals 2 ohms plus our RL, which is in this case 5 ohms. So REQ equal to 7 ohms. And we're going to place this R with our REQ here, and then we'll rewrite it. 5 volts equals IRL times 7 ohms. And then we'll rearrange our circuit to get 5 volts over 7 ohms equals IRL. And this will be our answer. So next, we will assume that RL is equal to 10 ohms. So we'll do a very similar process as to what we did before. Redraw the circuit, 5 volts, 2 ohms, A, B. Our RL in this case will be 10 ohms instead. And then we'll do Ohm's law again. So V equals IRL times REQ. So we'll have 5 volts equals to V, IRL is unknown, times our REQ, which is 2 ohms in series with 10 ohms from RL. So I'll have REQ equals to 12. And then we will do redraw our equation. 5 volts over 12 ohms equals IRL. And this is equal to 0.4 amps. So our last step is to act as if RL is equal to 15 ohms. So we'll do the next step. Redraw the circuit like always. 5 volts, 0, or have our source, 2 ohms resistor. We'll have our B node and our A node, and then we will have our RL, which in this case 15 ohms, and then we'll do Ohm's law again. So we have V equals IRL times REQ. Our REQ will be equal to our 2 ohm and 15 ohm resistors in series. So 2 plus 15 equals 17 ohms for our REQ. And V will be our source. So 5 volts equals IRL times 17 ohms. Then we'll redraw our circuit. 5 volts over 17 ohms equals IRL. And in this case, it will be 0.2994 amps. To conclude our problem, we found that VTH is equal to 5 volts, RTH is equal to 2 ohms. When our RL was equal to 15 ohms, we found it to be 0.294 amps. When our RL was equal to 10 ohms, we found that it was 0.416 amps. And when RL was equal to 5 ohms, we found it to be 0.714 amps. That is all for this problem. Thank you. I don't know what else to say.